teacher. Is my is our presentation about our midterm project material classification. My team have two member. It's me, Trần Quang Thành, and Nguyễn Văn Khải. My presentation have a four content. The first, we go to preface. The deep learning material classification project is a research project aimed at building an accurate and automatic material classification system using UVCAP-B radar. Used with both practical application, this system can be applied in many fields, from industrial production to scientific research. For midterm project, our goal to build a neural network from scratch to classify 8 class of material: air, aluminum, book, CD, copper, cup, note, plastic. The neural network is very simple. Just have two hidden layers. The main component of this project include data collection, preparation, building and deep learning model, training and evaluating the model, and then deploying a real-world material classification system for the final project. The next is our workflow. The first in workflow is connect data with your Novenda radar for collecting material signal, convert them to file .csv, and then access them with pandas processing. We split input dataset into chain and test path, apply neural network for classify them. Chain a number of neural network hidden layer, chain learning rate until receive good result. The last is evaluate model based on accuracy and evaluate model.
So the next section is about the data sets. The data sets are collected by Novena Radar. They are signals of 8 materials, including air, aluminum, book, CD, copper, cup, note, plastic. In 1 minute, you can see two figures here. So the distribution of these 8 materials in 2D and 3D after normalize them. Yeah. And about the model, we set up train and test set and initialize parameters. The data set is split into 80% of train and 20% of test. We initialize weights to very small random number with fitting with input data, and initialize bias to red zeros. For the forward propagation, we declare Z1, A1, Z2, A2, and Z3. For backward propagation, we calculate DW3, DW3, DB3, DW2, DB2, and DW1, DB1, and update parameters by minus them to the learning rate times DW or DB. Depends on the parameter is W or this weight or bias. And we have this is our cost, a figure about cost. You can see the epochs here is up to 50, and the cost is conversion after 45 epochs. The cost is smooth, so that we use the learning rate is 3 to the minus 10th power. So since the cost is smooth, the learning rate works well. That's our presentation about our midterm project. Thank you for listening.